Hello, good afternoon, everybody. So this is Ricky on behalf of Ultipa. So today we're going to talk about our new book, uh, GQL, the arguably the first GQL book. So, when the GQL standard was released last year, we thought about it and we thought, on the one hand, we need to make sure our graph database is conformant. So I guess we started supporting our initial release supporting GQL was back in September, and that's also the time, the publishers from Packet reach out to us. So they were asking if we were interested in, writing a book about GQL. We thought, why not? This is a great effort, parallel to our product development. Um, So a little bit background, like, oh, we all know this, like all the people in this room know this. Essentially, we're talking about the industry landscape from a very fragmented. We got all kinds of maybe around 10 dialects of GQL to standardized edition, and that's a great thing. And also, who doesn't like the beauty of GQL potentially if you are trying to do a lot of the table joins as you do in SQL, and that can be really a torture. So, and this is the really the simplicity and even the intuitiveness of GQL can be a killer. And now the publishers are really pushing this book. So major discount. I took an Amazon screenshot, and that looks great. A little bit about all the authors and the reviewers, uh, including myself and two of my colleagues, like Jason Yuri. So we are all engineers. Essentially, we all came from engineering background. And we also want to thank Keith, because Keith spent a lot of time and he's detail-oriented reviewing the entire book. Uh, we went over the book multiple times, and a lot of great inputs really helped us, improving the book's contents. So a little bit about book, the overall of the book, we divide things into 13 or 14 chapters. I think there are a couple of chapters really important, like, the GQL basics, exploring all the expressions, operators, working with like the GQL functions. We had a chapter dedicated to advanced queries and also like configuring sessions, transactions. That's definitely something we need to pay attention to. And also, we found out that some real users, readers, they like chapter 10, like conformance to the GQL standard, and also beyond GQL, which, where we speculated what's going on with GQL, even though, like some reviewers and readers, they have a different opinion. And the most interesting part is the case study, because we put in some real world case study. But we were, I think we were thinking about putting in 3 real world practical scenarios, but that may be too much. And at the end of the day, since a lot of people are interested in understanding how we handle financial crimes, anti-fraud, real-time fraud detection, so we concentrated on that particular case. And since we are giving out a lot of real world, not real world examples, I mean a lot of GQL queries. So we need a place for the readers to be able to play with those queries. That's why we created the GQL Playground. It's kind of like the stripped down version of our Graph DBMS, which is Ultipa Manager. But anyway, this is a GQL Playground. So basically here this is like forever free edition. User can create multiple graphs and switch between them. And also, there's a GQL editor. What you see is what you get with like sample GQL queries, a lot of online documentations. And so this is like you on the left-hand side, you have the GQL queries. On the right-hand side, you're going to see your results in real time. And you can play with the query results. It doesn't have to be just the graph view. You can also see like, a list view, which I'm going to show. Yeah, okay, this right here. So there are multiple ways to it. And you can also there are different kind of a layout, tree, forest, 3D, and etc. So in chapter 1, we talk about why the world needs, GQL on top of its 40-year-old SQL. And a lot of people finding this part, because we talked about this particular case, that why explainability and the ability to deeply traverse the data set with connected data set can be very meaningful, especially given the AI, the agentic large language model stuff. This is a perfect example. Like I just want to, point it out here. Like you might want to search something, the relationships between any two entities or multiple entities. For instance, like what's shown here, what's the relationship between Isaac Newton and Genghis Khan? And even today, all the LLMs, they're going to tell you there's no relationships, except both are male, very famous people, and that's it. We know this doesn't make sense. And if we were able to, import Wikipedia data into the graph database, then we conduct a shortest path search or some sort of a causality search. We're able to show something like, Genghis Khan started the Mongol invasion of West Asia and Europe, and which, like all the historians agree, the Mongol invasion really triggered the Black Death. This is a major historical event. And the Black Death lasted multiple centuries. And the last major outbreak was the Great Plague of London. Then Newton, now this is getting very close to, the time-space continuum, like where Isaac Newton was in the 17th century, and he was basically invaded the Great Plague of London, whatever, while he was attending the Trinity College. So we are basically using this case to show when a graph is deep query capable, we can make it white box explainable. It's something that the LLM couldn't handle today. And also, especially if your graph database the graph computing engine is able to refreshing the data in real time, that's going to be even better. That's exactly what we have been working on. So I want to talk, lastly, I want to talk about the real world graph solutions. So pretty much all the graph database today, we started with some sort of, we're calling that FRAMO, financial risks, fraudulent, anti-money laundering stuff. And there are RDF kind of graph databases or graph stores. They work a lot on knowledge graph scenarios, recommendation, supply chain, logistics, cybersecurity. All the cybersecurity companies today are adopting some sort of a graph technology. But we are also seeing, from our personal experience, we have been using our graph database to serve, especially RegTech, like compliance, auditing scenarios, and even in backend scenarios like asset liability management. This is because we don't see major players, we don't see Neo4j handling this kind of scenario. We don't know why, but one thing we do realize, traditional SQL relational database players like Oracle, especially OFSA, Oracle Financial Services Analytical Applications, they have they probably have 100,000 people, maybe not that much, maybe 50,000 people working on creating financial applications on top of the the Oracle Graph Database. So this is our area, like especially over the past like 5 to 6 years, after we have built some real world scenarios, and we were able to see using graph database, especially today, like over the past 1 year, using GQL, we can really accelerating, building truly interesting, innovative ALM or auditing, all the other kind of use cases with much lower cost. Like the total cost of ownership can be much lower, and the overall system performance can be much better. And in terms of the user engagement and user experience can be so much more improved. So this is great stuff. So we're gonna like continue to promote GQL. So lastly, I want to share with you, like the publisher just told us yesterday, they are also selling the books, promoting the books over their official portal, which is PacketPub. And if you are trying to get a copy, you can get author discount. It's shown here, 35 GQL on paperback and 25% off on ebook version. So that's all my sharing for today. All right, thank you.